For example, if we have something like this, x plus 5 equals 11. On this side of the left hand side, we have the unknown. We need it to stay alone, so we have to take every other number on that side to the other side. In doing that, there are steps we also have to take. In doing that, there are things we have to do, and that's what I am coming to now. So remove every number or term on the side of the unknown, this other side, or on the side where the unknown is. Every number with the unknown, remove it from that side so that the unknown can stay alone. To do this, we subtract positive numbers. Subtract positive numbers or terms which are added on that side to the unknown, to the variable. So with this as a case study, e.g. in x plus 5 equals 11, we have that since 5 is positive, since it is positive, we have to subtract it from both sides. From both sides. Again, that is the balancing. So this is what we're going to do. Subtract 5 from both sides. Subtracting 5 from both sides. In the beginning, these statements are very important until you are very used to solving equations. So we have x plus 5. We are doing what we have said. On this side, we subtract 5 equals 11. On this other side, we also subtract 5. So on the left hand side, we have subtracted 5. On the right hand side, we have subtracted 5. So we have this. 5 minus 5 is 0. What is remaining here now is x. And we have achieved our m. Achieved. Because it is a loan. So x equals 11 minus 5, 6. And that easily answers the question. What can we add to 5 to give 11? The answer is what? 6. The second step, the second thing we can do, depending on what we are given, add negative numbers or numbers which are negative or terms to both sides. So what we have here, e.g. if we have y minus 7 equals minus 2, we are simply asking what is the number from which 7 will be subtracted to give us negative 2. It may be easier for you to answer, but how to get that may not be that. So add negative numbers. So this is a negative number. 7 here is negative. Because it is negative, to remove it from the left hand side where we are seeing it, to remove it and take it to the right hand side, we have to do the opposite of what is there. Adding 7 to both sides. So we are adding so as to cancel the effect of that negative sign. We are doing the opposite. So we have y minus 7, we add 7, equals minus 2, we add 7. On this side, 7 we cancel minus 7, Y is alone now. Alone. Y is alone now. And our M is achieved. Y is now minus 2 plus 7. We know is 5 plus 5. So that is what our Y is. What it means is the number we remove 7 from in order to give negative 2 is 5. Or rather, the number we will add to a negative 7 to give negative 2 is 5. It's only one number that can do that. That is what you call the solution to equations. The third step you can take, depending on the question given to you, look at what you call coefficients. Coefficients are numbers which multiply variables or unknowns. So whenever you see a number multiplying an unknown, that number is called the coefficient. So here we do the opposite of that multiplication effect. We do the opposite, and that opposite is division. So we say divide. Remember, it has to be both sides. Divide both sides by any number or term which multiplies the unknown, or that is the coefficient. So this is what we have. For example, if we have 4x equals 24. X is the unknown, which is not alone. But this kind of attachment is very much severe because it is by multiplication and not by addition. It is easier to separate attachments by addition than to separate them. So, since it is multiplying, since 4 is multiplying the unknown, we do the opposite of that action. We perform the opposite operation. Performing opposite operations, we say dividing. We are dividing because of this multiplication of operation here. Dividing both sides by 4. Because it is 4 that is multiplying the unknown. So to remove 4 from there, we have to do the opposite in order to detach it. 4x over 4. Both sides, remember, equals 24 over 4. 4 can neutralize 4 here, cancel 4 here to give 1. 1 times x is x. 4 into 24 is 6, so x is 6. What this is telling us is that the number that multiplies 4 to give 24 is 6, which you and I know is very true. Finally, but not actually the final one, we have numbers which are divisors, which are dividing the variable, which are attached to the variable by division, reciprocals of whole numbers. We see them like this. I will have to say two things about this, but let's move on. We say multiply, because they are dividing, we do the opposite operation. Multiply both sides by the number or term which divides the unknown. Sometimes it is easier to say it this way because I will soon do something that will talk about what we have done before. Now, if we have something like this, e.g., for example, we have p over 3 is equal to 5. they're asking us, what number will be divided by 3 to give 5? We know the number. We know it's 15. But how are we going to get that 15? That's in solving equations. So we have P over 3 equals 5. Because 3 is dividing, we multiply both sides by that same 3. So we are performing the opposite operation, multiplying both sides by 3. We have P over 3 multiplied by 3. You know, this 3 is the same thing as 3 over 1 was 5 multiplied by 3. 3 can easily cancel 3 here to give 1. 1 times P is P. Then the other side, 5 times 3 is what? 15. Please, always make your equal signs. When solving problems in mathematics, let your equal signs be aligned on a straight line. So this is an error actually. So that it will keep your work neat. So we have P is 15 here. In all these things, we can see that we are performing the opposite operation. The operation in the question, in the equation, given equation, in order to neutralize it, in order to find the unknown, we have to do the opposite operation to what is in that equation. If we have addition, we subtract. If we have subtraction, minus, negative, we add. If it is multiplication, that is the relationship, we divide. And if it is division, like this, we multiply by the numbers involved. Now, look back at this question. P over 3 equals 5. You will see something. This is the same thing as 1 over 3 P equals 5. In that way, 1 over 3 is also a coefficient of P. 1 over 3 is a coefficient of P. It's a coefficient of P. So we can apply the division we did here because it is multiplying P. 1 over 3 is multiplying P. It's a bit different from saying 3 is dividing P, but they are the same thing. It is here 1 over 3, the coefficient is multiplying P. So if you say on a more advanced level, dividing both sides, because it is multiplying, if you say dividing both sides by 1 over 3, you will still be saying the same thing because you will say 1 over 3 P divided by 1 over 3 equals 5 divided by 1 over 3. And we know in our mathematics, once we have stuff like this and change it to multiplication, it becomes by 3 over 1, 5 times 3 over 1. This is correct because we have something like this. 3 cancel 3, 1p times p is p. 1p times 1 is p, 5 times 3 is 15. So you see, I have given 4 steps, but in principle, there are actually 3 steps because the division is a multiplication by the reciprocal of that number. So I hope this makes a bit more sense to you. So we have concluded the 4 major operations in solving equations. So we will now look at other stuffs such as roots and power. Roots and powers. So to be in a more simplified way, a root is written this way. What is here at the curved end of the root, at the hook, what is inside the hook will tell you the type of root it is. We have this as a square root, which is the same thing as, if you have x inside, this is the same thing as x to the power half in your indices. Remember that? If you have 3, we didn't write 2 here because The 2 here is invisible actually. That's the simplest root, so there's no need writing it. If you see it this way, it's a square root. But if it's not a square root, you must have something there, a number there. So you have cube root. If it's cube root, we have cube root, which is written as x raised to the power 1 over 3. So you see that roots are fractional indices. 4, fourth root. Fourth is 1 over 4, remember that? Fourth root, x raised to the power 1 over 4, up to any root at all. If you have n here, you call it nth root. Nth root, which is x raised to the power 1 over n. To neutralize this root in an equation, you do the opposite. The opposites are powers. X raised to the power 2 is a power called squared. This is cubed, and so on and so forth. This is to the power of n. To the power of n. So since these ones are opposites of these ones, they are opposites. We apply each of them when we encounter. For example, if we have e.g. 2 roots x equals 5, something like this. We are looking for x. First of all, there is a number multiplying the x inside the root. There's a number multiplying the root x. We have to do away with that number, that is 2. Because it is multiplying, we divide. Dividing both sides by 2. We have 2 root x over 2 equals 5 over 2. So we are left with root x equals 5 over 2. So to solve for x, because x is not alone here. X is not alone here. So we have to remove this root, which is like a prison, by doing only one thing. Do the opposite. Square it. Square. So you put it this way, squaring both sides. You have, when you square a square root, it cancels the root. I will show you that using indices. Square this side too. So x comes out, it becomes 5 squared is 25, 2 squared is 4. This is the same thing as 6 1 over 4. Now, look at this implication sign. From here, I can tell you, since I have shown you that square root is raised to the power half, this is x raised to the power half equals 5 over 2. So it is simpler to know that what we have to do to this is to multiply the power by 2. Multiply the power by 2. That is squaring. Multiplying the power by 2. It's the same thing as squaring. Squaring both sides. So when we square here, we also square here. You see, it's easier now to see that 2 will cancel 2 here up. It's x raised to the power 1, which is x, and we have 25 over 4, which takes us back to this. So it's easy. So when we have the other one too, x squared equals 49. Okay, let's use 2x squared equals 98. We do the normal thing, remove the 2 by division because it is multiplying. So you're dividing both sides by 2. When we do that, we know we will get 49. X squared is 49. When we take the square root of this, taking the square root of both sides, okay, we have okay, so x, this will cancel off. X is square root of 49. Square root of 49 is 7. But there's a twist to it. This is 7. But then, to find a root of any number, especially the square root, there's plus or minus attached to it. What it means is this: x could be plus 7, x could be minus 7, either plus 7 or minus 7. Because if you square plus 7, you get 49. If you square minus 7, you also get 49. So square root of 49 is plus or minus 7. It's simple that way. So we have done something concerning equations, simple equations and algebraic expressions. So I will now quickly go to word problems.